right, section 112, we're taking a look at equations. So it's just equations day 2, just furthering our discussion of what we began last time. A reminder about what the word solution means. We've been finding solutions, we've been solving. A solution is simply a value that makes an equation true. And we talked about this briefly in terms of like, how can I check my answer last time? So it's a value that makes the equation true. So we're going to actually do a couple problems that I was mentioning last time where we're checking to see if something is actually a solution. So the equation that we are being given is 17 equals 6x minus 1. And problems 1 and 2 both propose a potential solution. So if we're checking to see if it's actually a solution, it means that we are going to evaluate and see if it works. So it's much like we're really asking a question right here. Are these going to be equal when I'm done? So I've got 17 on the left. What is 6 times 8? 48. And 48 minus 1 is 47. 17 is not equal to 47, right? It isn't. So this is not a solution. Or you can just say no. It didn't work. We're going to do the same thing. We're going to try the number 3. So 17, 6 times 3 minus 1. So what is 6 times 3? 18, and minus 1 is 17. And this one actually works. So yes, this is a solution. Or you could say just yes. So I mentioned it last time. We didn't actually do a problem with it. You're going to have a few here in this section where you are going to do those and check to see if something's a solution. But you can actually check all of your work to make sure that the answer you get really is a solution as well. So we're going to continue our discussion of solving equations, but they're going to be getting more complicated today. Okay? More steps. Last time we did one-step equations first. All you had to do was one piece. And then we did two-steps equations where we had to do two things. And in this lesson, we've got more going on. So on number 3, we see that there is addition and we see that there is division. And just like we talked about last time, we're going to be working from the furthest out, right? The far away pieces from X inward. So what am I going to deal with first? The addition of 23 or the division of 7? Division. Right. So how do I undo division by 7? Multiply. Right. Great. So we're going to multiply by 7. So on the left-hand side, those will cancel, leaving me with x plus 23. And on the right-hand side, what's 3 times 7? 21. Okay, what's next? Right, subtract 23. And what is 21 minus 23? Negative 2. And just for good measure, to show you that it's really going to work, because I actually haven't shown you one that we've done, we're going to just check it by taking the original equation and plugging it in. So we're going to take this equation and we're going to put it in where I have negative 2 plus 23 over 7. And what I want to know is, does it in fact equal 3? So what's negative 2 plus 23? 21. And what's 21 divided by 7? 3. So it does in fact equal the 3 that I was anticipating or hoping that it would equal, right? So you can check your solutions. I'm not going to check every single one, but you could check every single one if you wanted to make sure you got it right. All right, more going on number 4, but it's not quite as ugly because there's not that fraction involved, of course. So when we have more going on than just 2 steps, sometimes we have a problem like this where there's some things we can clean up or simplify or combine on one side of the equation. So on the right-hand side of this equation, do you see pieces where you could combine them? Yeah. Yeah, the 3y and the negative 8y. So everything that I'm not combining, I'm going to rewrite. That is the negative 31, and I'll have my positive 9 here. But what is 3y minus 8y?
Negative 5y.
Yeah, negative 5y. And now the problem actually is like we were dealing with last time, a two-step equation. So what would I do first?
Subtract 9.
Yep, I'll subtract my 9. So what is negative 31 minus 9? Negative 40. And I have negative 5y on the right, because those added to 0, of course. And then what? Right, I'll divide by negative 5. Okay, so negative divided by a negative is positive, and 40 divided by 5 would be 8. So my solution on the second one is y equal 8. Okay. A couple more. On number 5, we see that it looks a little bit like 4, but I don't have things within the same side that actually simplify, right? They're split up. I have a constant term on both sides, an 11 on one side and a negative 7 on the other, and I also have a y term on both sides, the 15 and the 13y. So the goal is still the same. I want all the y's to be on one side and all the constants to be on the other side. And it doesn't really matter which direction you move things. So let's start with collecting the y's on the same side. Do you want to move the 15 to the right, or do you want to move the 13 to the left?
13 to the left.
Okay, so if we want to move the 13, then the opposite operation, then plus 13 would be minus 13y. And that would be our first step. So I still have 11. 15y minus 13y, 2y. And it equals negative 7. What would the next step be? Subtract 11. And if you wanted to do the subtraction of the 11 and the subtraction of the 13y in the same step, that would be okay. You can do that. If I do that on this problem, of course, these cancel, which was my goal. I have 2y on the left, and I have negative 7 minus 11. What is that? Good, negative 18 on the right. And my last step would be to do what? Great, divide by 2. So y is negative 9. Okay. The second one down here, what do we see happening on number 6? Yeah, the parentheses we can distribute through, right? So let's do that. We'll start with our 25 on the left. What's 7 times y? And 7 times negative 5? Wonderful. And then I have my positive 3y. Now the problem actually looks quite a bit like number 4 over here, doesn't it? So I have some pieces that are on the right-hand side that I can, in fact, combine. I have like terms with the 7y and the 3y. So I'll rewrite my 25. 7y plus 3y is 10y, and I have minus 35. Now what? Add 35. $25 plus 35 is, so 60 on the left, 10y on the right, and I'll divide by 10. Okay, you notice I switched the y and put it first. I have a tendency to do that. You can certainly leave it on the right-hand side and it would be just fine. Y is 6. Any questions on that one? Okay, we have one more before we get involved with some fractions again, okay? Oh, I'm going to show you something so cool about fractions. You're going to be like, oh, wow. You are, I promise. I promise. But we're not there yet. Okay, what do we notice on number 7? There are 2 distributions. Very good. So I have this piece and I have this piece. So we have lots of pieces here. I have negative 5 times negative 4u. 20u, and then negative 5 times 5. Negative 25. I still have the minus 9u. Don't forget the pieces that are there and not being used right at the same time. 5 times u is 5u, and then I have 5 times negative 7, negative 35, and minus my 6. Okay, so consolidating, cleaning up within the individual side that it's already on would be our next step. So on the left-hand side, what two pieces can be combined? Yeah, the 20u and the negative 9u. So what does that give me? 11u, right? Minus 25. On the right-hand side, what pieces can be combined? Yep, the 35, the 6, they're both negative. So what's negative 35 minus 6? Right, negative 41. Thank you. You guys do such a good job of just giving me answers. I really appreciate it. I have other classes that just stare at me and I'm like, I know you know the answer. Say something. All right, awesome. Now, we're going to have to move some things around. Let's deal with the u's first. Do you want to move the 11u to the right or the 5u to the left? 5u. Okay. So 5u is a positive 5, so we do a negative 5u. So I have 6u minus 25 equals, so these add to 0, and I have negative 41. Now what? Yeah, it can add the 25. So I have 6u on the left. Of course, those added to 0 as well. I have negative 41 and I have positive 25. So my sign's going to be negative. The difference between them is 16, right? Okay, so remember, integers, keep the sign of the bigger one. Subtract them like you would as if the bigger one, it was bigger minus smaller. Wonderful. And then what? Divide both sides by 6. Okay, so somebody tell me what happens in your calculator if you tell it 16 divided by 6. Okay, so we get a repeating decimal, right? Okay, so this is one of those ones I warned you about last time. I just didn't have an example in the notes that we did last time. So when that happens, what that means is that we're not going to write that decimal answer down, right? Because it has a repeating decimal form. But what we can do is we can look at the 16 and the 6 and see if they reduce to keep it in fraction form. And they do. How will they both divide? Yeah, by 2. So 16 divided by 2 is 8. And 6 divided by 2 is 3. And that 3 in the denominator is exactly what's causing that repeating decimal business going on, by the way. On this problem, anyway. All right. I promised you something cool. So the actual part of this direction changed, right? Our directions before this simply asked us to solve. I don't even have it written down, but for 3, 4, 5, 6, and 7, we were just solving, okay? Notice my directions here, at least on my slide. They're not actually in your notes. I apologize. It says to rewrite the equation so it does not have fractions. So I know that fractions are not y'all's favorite thing. At least I've heard a lot of grumbling about them, so I'm guessing that's true. And you're not alone. A lot of people feel that way about fractions. But what if you could actually make the fractions go away? That'd be pretty nice, wouldn't it? Yeah, absolutely. So that's what we're going to do. We're going to actually make the fractions go away. The way that we do that is we look at what the denominators are, and we compare them. So I've got a 4, and I've got a 10. And what I want to find, I'm going to do this 2 different ways for you. We're going to do one way where we find the least common denominator. We've done that before. And one way where we use a common denominator. And we've found that before as well. So these are my denominators. So if I'm doing the least common denominator, what we've done in class is we've said, okay, well, I can take the 4 and I can take the 10, and I can break them down, right? 4 is 2 and 2, 10 is 2 and 5. And then what I do is I take the pieces that match and I sort of eliminate them. You all right? Everybody with me so far? I eliminate the pieces that match. And what remains, this 2 would be multiplied by the 10, or you could say that this 5 would be multiplied by this 4. And either way you do it, you get the same number, and the least common denominator then is actually the number 20. everybody with me on that? Okay, so that's how we've done least common denominator. There's actually lots of ways to do least common denominator, but that is one of them. What we're going to do is we're going to take the entire equation and we're going to multiply each separate term by 20. So we're going to multiply 2 times 20 minus 3 over 4 times 20. And if you want to write it as 20 over 1 because it's fractions, you can do that. Equals 9 over 10 times 20 or 20 over 1. So the first one, 2 times 20 is 40, so that's, fine. What do you notice happens along the diagonal on the second one, the second term? Yeah, that 4 cancels with the 20 and leaves me with what? A 5 on top. What's 3 times 5? 15. So this is now minus 15. Did I have a variable somewhere? I did. There was an x here. So sorry. I'll put it with the 3. There's an x on that term. I just left it off. It needs to be there. Don't leave it off. On the other side, what do you notice along the diagonal?
Oh, the 10 and the 20.
They do. The 10 and the 20 cancel, leaving me with 2. 9 times 2 is 18. How do you feel about that equation?
That's a lot better.
That's a lot better, isn't it? That equation that's in the box is a lot better than the first one we started with. Okay? So that's how you can do it with least common denominators. Let me show you how you can do it with common denominators. Common denominators mean that we just multiply the two denominators together.
Wait, is that the answer?
It is for the question. It just says rewrite the equation so it doesn't have fractions. That's all I'm doing on this particular problem. When we flip the page to number 9, we're going to solve them using this idea. But I just wanted to have one problem. I'm sorry, the directions I obviously didn't, when I was typing this up, did not get the directions written on that particular problem. But once we flip to the next slide, we'll continue solving and so forth on the problems. If you wanted to do it with common denominators, so you just don't like to do the whole, like factoring down, breaking it down, you're afraid you might make a mistake, something like that, it's okay. You can do it with common denominators. You just multiply the two denominators together. The numbers end up being a little bit bigger. That's the only caveat to it. So what is 4 times 10? 40. So instead of the number 20 being multiplied by everything, we're going to multiply the number 40 by everything. So we're going to have 2 times 40 minus 3/4 x, or I'm going to write 3x over 4. And it's times 40. We'll write it as a fraction, 40 over 1. Equals 9 over 10, again, times 40 over 1. All right, 2 times 40 is 80. Look along the diagonals, because it'll always cancel. That's the whole point of what we're doing, is things are going to cancel. Yeah. So the 4 and the 40 cancel with 10, so I have negative 30x. This 10 and this 40, cancel, giving me a 4. So 9 times 4 is 36. I fully realize that that's not the same equation that I got in the other one. I get that. It wouldn't be. I multiplied by something different. But if the directions are this, I've still answered the question in a way that eliminated all the fractions.
Would you end up getting the same answer?
Yes, you would. Yep. If we continued on and we solved this particular problem in either direction, we would get the same answer. Okay. So, I'm sorry.
Sorry, so even if you did it that way, you still need your answer?
Yes, because this question just asked us to rewrite it with no fractions. So be real careful, because I did leave the directions off of your homework, but on your homework, off of your notes, but on your homework problems, it will actually show you, those directions. So just be real mindful of the fact that it doesn't always have the directions that say to solve.
Yeah.
Sometimes you're doing something different. Okay, so now we are going to solve. You see my directions did change in this one, right? But we're going to do this by, again, eliminating fractions. And I've got three examples for we're going to do that. And I'm going to let you guys pick. And maybe we'll pick sometimes to do least common denominator, or maybe sometimes we'll pick to do common denominator, or maybe you always want to do it one way or the other. I don't care. So which would you prefer to do on number 9? Common denominator or least? Least. Okay, so if we're going to do the least common denominator, the first thing we have to do is to figure out what that is. So I can do it from where it actually is. There's two denominators here. I know there's three, but there's only two different denominator values, right? Everybody good with that? Okay. So I only have to consider the different values. 8 breaks down into
4 and 2,
4 and 2. And I know the 4 breaks down, but just hold tight. The 6 breaks down into
3 and 2.
3 and 2. The 2's match. 4 and 3 don't. And I know 4 can break down, but it doesn't break down and reduce with the 3. So don't necessarily have to keep going. So if I multiply 4 times 6, or 3 times 8,
24.
I get 24. 4 times 6 is 24. 3 times 8 is 24. You multiply it by the factor it does not have. So the least common denominator is 24. 24 is my magic number. It's what's going to eliminate all my fractions. So I have u over 8 times 24. And I'm going to write them as 24 over 1 minus u over 6 times 24 over 1 equals 7 over 8 times 24 over 1. If you don't like least common denominators, you can multiply 6 and 8 together and use a common denominator. You'll get the number 48. You'll be multiplying something a little bit bigger, but it'll still work. Okay, so all these denominators should reduce. Let's check and see that we do. 8 and 24 reduce to leaving me with what? 3. So I have 3u. The 6 and the 24 reduce to give me what? 4, so I have minus 4u. The 8 and the 24 reduce to give me what? 3, so now I have 7 times 3, which is 21. 3u minus 4u is what? Negative 1u or negative u equals 21. And then what? Multiply by 1, divide by 1, change your signs, whatever language you want to use. You got negative 1. So the u value is negative 21.
I think I like least common denominator better because I don't have to use such big numbers.
Yeah, I mean, it's the benefit of it for sure. The next problem actually doesn't even matter whether you use least common denominator or common denominator because they're the same. 3 and 5 don't factor. Everybody with me on that? So the least common denominator is actually the same as the common denominator here, which is 3 times 5. So 15 is our magic number. Okay, so each of my fractions I'm going to multiply by 15. So I have negative 5 over 3. I'm just going to say let's always put the x on top. It needs to go somewhere. We'll put it on top. And it's times 15 over 1. Minus 4 over 5 times 15 over 1 equals 4 over 5, 4x over 5 times 15 over 1 plus 3 times, and I might as well just write 3 times 15 on that one. Okay, let me pause for a moment and sort of give just a real quick check to make sure that everybody understands why I'm allowed to do what I just did. The reason I can multiply each term by 15 is because what I've really done is multiply this whole side of the equation by 15 and this whole side of the equation by 15, and I've distributed. As long as I do the same thing to two sides of an equation, that's a valid operation, right? And then I've distributed the 15 through. So that's what's actually going on sort of behind the scenes that I might not have explicitly said already. Okay, all those denominators are going to cancel. 3 cancels with 15 to give me 5. So I now have negative 5x times negative 5, which is negative 25x. In the middle, I've got 4 over 5 times 15 over 1. So this 5 and this 15 cancel to give me 3. And then the 4 times the 3 is 12, so negative 12. I've got another 5 and 15 to cancel to give me 3. So I've got another 12, but this time it's 12x. And then 3 times 15 is 45. Okay, so we've achieved the whole I got rid of the fractions part. Now I need to put the x's together. I need to put the numbers together. So do you want to move the negative 25 to the left or the 12 to the right? I said that backwards. Negative 25 to the right or the 12 to the left? Yeah, we're split now, aren't we? Okay, so some of you are saying, I want to move the negative 25, and my guess is because you want to deal with positive numbers. Some of you are saying, I want to move the 12 because either you like moving smaller numbers or you like to always have the variable on the left. Okay, so it doesn't matter which one you do. You can pick your favorite. I'm going to move the 25. I tend to err on the side of the positive numbers myself. So this is going to be 0. I have the negative 12 over here. 12x plus 25x is 37x plus my 45 rather. What would I move next? Let me subtract to the 45. All right. So what do we have? Negative 57. Boy, that's ugly. That's what it is, actually. It's just ugly. All right. And then what would I do? Divide by 37. Let me make this all just a little bit smaller. All right, so such is life. It's just ugly. One thing that it might be sort of wise to be aware of right now is that 37 and 57 happen to both be prime. If they weren't both prime, we would reduce them if we could. They simply don't reduce. So the answer I actually have on this problem is negative 57 over 37.
Can I just put the decimal?
There's a sign error. Pause. We all did it. No, I've just got this is actually in the wrong place. There we go. Never mind. My parentheses got moved. We're okay. Okay, cool. What was your question?
Could I just put the decimal instead?
What does the decimal say? Because I'm going to guess that it's not so pretty.
1.5405404.
All right. So does it sound like that is a terminating decimal, Maxwell? No. It's a repeating decimal. So we're not going to leave it in repeating decimal form. Yeah. I know, it was a valid attempt. All right, we've got one more fraction one. Okay, any questions on that one? That one was an ugly one. The next one I think works out prettier. Okay, hopefully. All right, 4 and 2. I bet you know what to multiply by to get rid of both of those. Yeah, they're not all ugly, right? It's just 4. 4 will do it for me, so it doesn't have to take a lot of work sometimes to come up with that number I need to multiply by. It is 4. So I have negative 3x plus 3 over 4 times 4 over 1. And I have minus 2x plus 3 over 2 times 4 over 1.
Wait, how'd you get 4?
Because,
No.
I didn't get it.
okay, okay, you can use 8. 8's not a bad thing to use. But if I multiply the 2 in the denominator by 4, will it eliminate the denominator? Okay, guys. Here's the number 4, and here's the number 2. How does 4 break down? 2 and 2. So what's missing? A 2 is missing. If I multiply 2 by 2, I get 4. I don't need to multiply 4 by anything to get 4. It's already there. Think about what would happen if you wrote out a list of values. What are the multiplication tables of 2's? Well, it goes 2, 4, 6, 8, 10. What are they for 4's? 4, 8, 12, 16. What's the least common, or the least one? It's 4. 4 is the least common denominator for 2 and 4. If you use 8, it's going to be fine. You're just going to end up with slightly bigger numbers. It's not even awfully big this time, but 4 is enough. Because take a look here. Those 4's just cancel, right? And this 2 and this 4 cancel, giving me what? 2. Negative 3 times 4 is? Negative 12. I have negative 3x plus 3 from the numerator there. We have to be a little bit careful about that sign. That sign goes through everything. So the 2x is negative and the 3 is negative because it's got a negative sign in front of the whole fraction. Okay? And I'm going to be multiplying those values by 2. So negative 2x times 2 is negative 4x. And then I've got the negative 3, right, from here, because it's got a negative in front of it. It's negative 3 times 2 is negative 6. The negative has to distribute through. Yep, Maddie.
Why didn't we do that on the first one?
On the first one, because I had it written wrong when I wrote it. We should have. Thank you for catching that. I appreciate it. We should have. The negative was in front. It should distribute through as well. You're right. Good catch. Okay, let's do some cleanup. So this is negative 12. What pieces can combine on the right? Negative 3x and negative 4x, which gives me what? Negative 7x. And what else can combine on the right? Negative 3 and negative 6, which gives me negative 9. Now what? We're going to add the 9.
So negative 7.
So we have negative 7x on the left, or on the right. What is negative 12 and positive 9? Negative 3. It doesn't end up working out to be very nice, isn't it? Does it? Oh, there's a typo in my work. That's why. When I copied from one place to the next. All right, and then what? Divide by negative 7. It's not quite as ugly as the last one still. What was that? I'm sorry, I can't hear you, Kayla.
They can't like simplify.
You're right. They can't simplify. 3 and 7 both are simplified already. The negatives can go away, though, right? Yeah, so we could do that. It is definitely not a terminating decimal.
Are you sure?
I guarantee it.
4, 2, 8, 5, 7, 1.
Do you want to know a trick? I'm going to tell you a trick, Maxwell. Do you know what the trick is? If the denominator has factors that are anything but 2s and 5s, it's not a terminating decimal. So if the denominator were 10, you'd be good.
Maybe I.
But if you've got a 3, a 7, a 37, it's not going to work. Yes, ma'am.
Why doesn't it work to have them, all have the same denominator of 4? Like if you just multiplied that last one times 2, and then made negative 3, you multiplied it by 4, so you came out with 4.
Like to actually get common denominators?
Yeah, the original problem, yeah, just make them all have the same denominator.
You could. So if you changed this and you wrote it as negative 3x minus 3 over 4, and then you have negative 4x plus 6, because that's multiplying by 2 over 4, that works. Eventually, you're still going to have to get rid of the denominator as you continue through the problem to solve it. So it doesn't hurt anything, but you're still at the point where you still have fractions involved, right? So now at this point, I'd still have to end up multiplying everything by 4 to make it all go away, which is what I did directly instead. So when I would look for a least common denominator or a common denominator and I decide to multiply, it usually takes care of 2 steps at the same time, which is friendly. And it turns things out of fractions into whole numbers. So. Okay, we've got a couple problems left, but they don't involve fractions. Oh. How did I get rid of the negative 3?
Oh, no. Because you divided.
Are you talking about in the question Damaris asked right here?
No.
On that one?
Our answer.
Okay.
How is it not?
How to get rid of the negatives?
Yeah.
Because a negative divided by a negative is a positive. Yeah, the negatives cancel. Jasmine, are you good?
Yes, I just can't do it really fast.
Sorry. Okay. 2 more questions. Y'all ready? Okay. Yeah. All right, these are a little different questions, directions. Again, they're not on your paper. This is epic fail. I'm going to have to do some editing to this courseware pack thing. So write these directions above problem 12 and 13 so that you have the actual directions on there. An equation can have 0, 1, or infinitely many solutions. Every problem that we've done so far, today, yesterday, anything with equations so far, have all had one solution. So that's the norm, okay? That's normally what happens. So I want to give you an example of what happens when you do have 0, or infinitely many solutions. So we solve it just like we were doing any other kind of equation, but funny things are going to happen. So let's try that. What do we notice on the first one? We distribute. 4x plus 8 equals 4x plus 6. And if I try to get the x's to combine,
They just cancel.
they cancel. And in fact, that's what always happens in one of these two types of problems. The difference is what happens with what's left. If they cancel out the negative 4x and the 4x business, what do we have on the left? 8 equals 6. And is that true? No, that is not true. That's a false statement. When that happens, there's no solutions. So if this statement is false at the end, there's no solution. Let's try the other one. Okay, so we're going to distribute like I did in the last one, right? We have 8x plus 6. On the left, we can combine some things. I have 3x and 5x, which would be 8x plus the 6. Okay. They're exactly the same. And if I didn't recognize it immediately and I tried to do the same thing that I had done on the last problem, and I subtracted 8x, right, like I just did on the last one, I would end up with a statement that's actually what this time? True. This statement's true. When that happens, it means there's infinitely many solutions.
So would the other one, number 11, technically be 0?
Yeah, it would have no solution or 0 solutions. So infinitely many solutions, what that really means for the problems we're working on right now is that any number would work. Any number you plugged in on x would give you the same value on both sides of the equation. Okay? So be aware of that as you're working through those. If it asks you questions that have 1, 0, or infinitely many solutions, that's what you're sort of on the lookout for. All right, so section 12, our last section from Unit 1 is completed. We have a, what on Monday? A quiz on Monday. We'll go over questions and so forth. It will include radicals. I know it was your favorite. And equations, 2 sections of equations, all right? And then on Tuesday, we will review. Yes, study in class, you got. And then on Wednesday, we will take a test. Awesome. Have a great weekend, guys.